Welcome. This is the Embracing Digital Twin panel, and we're going to be talking about a journey towards digital twin. So everything from getting started, best practices, and then an outlook as to what we think is going to happen in the next 5 years. So it's quite a big promise, and I'm going to need you to also participate in the conversation. So if you have any questions, please raise your hand. There will definitely be a session at the end for questions, but definitely if you have any questions during the session, raise your hand, and we do have microphone runners coming. So my name is Teresa Tung. I'm a managing director at Accenture Labs, and I'll be your moderator. I lead a team that's done some of our first of its kind digital twin projects, and it includes everything from the what, the then what, and then the what if. So the what being able to have a view of your digital view of your physical thing. The so what, or what happens if you apply AI and analytics to that data in that single view. And then finally the what if, right? So what we're reaching towards is that if I can interoperate the twins with simulations and engineering designs, can we actually predict what's going to happen and how things come together? So I'm joined by a very esteemed panel, and I wanted each panelist to maybe introduce yourself and then your role as it relates to digital twins. So let's start with Brad.
Yeah, sure enough, Teresa. Thank you again for moderating the panel and bringing us all together. This is a real cool topic that we're going to be talking about. I work at SAS. I'm an IoT analytic architect, and what I'm doing with digital twins is basically taking analytics and artificial intelligence and putting them in the digital twins. And so I'll be talking about that. And when I talk about digital twins, we kind of go across industries. So we know probably a lot of people are familiar with more of the industrial use cases and things, but I do work in energy and utilities, do work in smart cities and buildings, and so for smart buildings, as was mentioned just a little bit earlier, you get into different facilities like sports stadiums and stuff. So how cool is that to start putting in all the IoT digital twin infrastructure into a sports stadium? Connected vehicles is another area. So I'm really looking forward to going through the panel today.
Hello, my name is Eric Harper. I'm with ABB, and I'm a technologist. I'm a generalist. I get to dabble in a lot of different things and get to help our customers create value with that technology. And I guess with regard to digital twin, I am a software architect, and I see digital twin as a key opportunity to take another fresh look at architecture, to be able to optimize the use of the resources and to be able to reduce the total cost of ownership.
Okay, so my name is Birgit Boss. I'm overwhelmed about the interest in the topic, but I think it's really worth the topic. So I'm with Bosch, and before somebody said, you are the one who are doing the washing machines. Yes, we are also doing washing machines, but of course we are doing much more. So Bosch is a very large automotive supplier. We have over 400,000 employees, and we also have over 270 factories worldwide. And so the topic of digital twin is very interesting, and another topic, I think we will talk about it later also, is standardization. And my role in all of this is standardization. So I'm the chair of the working group of the German platform Industry 4.0 on asset administration shell. And for me, asset administration shell is the digital twin of the Industry 4.0. And I'm also co-chair of the joint working group of the Industrial Internet Consortium and the platform Industry 4.0. We're working also on the synergies between digital twin and asset administration shell, for different domain, not only for manufacturing. So we will discuss this also later, I think. Thank you.
Thank you. So in the audience, how many of you are on the journey of digital twin? Can I see hands? Okay, so not as many as I thought. So I do have an initial question to start, right? So when we say something like digital twin, I think digital representation of a physical thing, that's easy to say. But what's the next step, right? So I think, Brigitte, in some of your role, you talk about this notion of semantics. Can you define what semantics are and how that relates to twins?
Yes, as you said, the digital twin is said to be the digital representation of entity, of an asset. And I think it's important to see that it's not a complete substitute of the asset. It depends on the use cases you want to solve with the digital twin. You only have to provide the information that is needed for the use cases you want to solve. So it's not about having the best digital twin on earth that is as close to the asset you have. It is about giving the information to your customer or whoever is using the twin that is needed. And as I said, it's about information, it's not about data. So we have a lot of devices, machines, all are very heterogeneous and all use different data models. They provide data and you don't know what is the meaning, or at least the meaning is different for every machine. And so the integration costs are very, very high because there is no, you have to understand every machine from scratch in a way if you buy a new one or something. So what we need is semantics. What does the data mean? And the digital twin is a very good vehicle for solving these semantic problems you have by providing the information in a standardized way. And that's, I think, it's one of the most crucial things if we want to solve the heterogeneity problem and the interoperability problem, to really have a common semantics defined for the data that is provided by your devices, by your machines, by your assets.
Can you give a concrete example of what one of those semantics are, right?
Yes. So when we start in Platform Industry 4.0, we start very small because you have to take one step after the other. So the first thing we always talk about, and that's not the easiest one, is identification. How do you identify your device? You need to have a global ID, you have a serial number, you have a manufacturer and all of this. And this is, it doesn't sound very exciting, but here semantic has to start to be defined. There is no standard how to do it. So there is work, for example, on an electronic nameplate. Very simple thing, but it's not yet standardized. So here we have to define the semantic also for such easy stuff. But of course, we also talk about measurement data, the temperature. If you get a number like 100 now, is it 100 Celsius? Is it 100 Fahrenheit? You don't know. This is the semantics you have to add. And where did you measure it? The location where your twin or your asset is located, not the twin. So you need to have a lot of knowledge about the data so that you can really use it for more enhanced applications in the end. And also, what I also want to say, a digital twin is not only passive. You can also trigger actions with a twin. So I know some think it's perhaps only passive, but you can also really, move things with a twin if this is your use case.
Wonderful. So the semantics actually give you that meaning of the data, right? So you store the data separately, but then this tells you what it means and how to use it. So I guess going to Brad, who's expert at the AI applications, do you have a specific view of the twin that is more AI-centric?
And the data part definitely plays into that, because all the data from all these sensors is what feeds the artificial intelligence and the analytics within there. So when I look at digital twins, I think of it as we all say, a digital representation of a physical asset or system, and system gets to be pretty large when you think about it. I want that digital twin to be something that I can look at and work with and explore, just like if I had that asset in my lab where I could tear it apart and poke at it and do things with it. So to get that same experience and that same benefit, I not only am going to take data from all those sensors that are on that asset, I'm going to take data from other assets like it that are in other places, because I want to learn what they're doing. I want to get data from things that are connected to it. So like when we were talking about smart buildings, I've got the chiller plant down in the basement. I got the air handlers, all around. I got the fan power boxes. Those are all connected together. So I need data from all those together, and then the environment around it. And you can think of that as the environment like in a building, or as I was mentioning with transportation, all the other vehicles that are around it and such. So now that I got all that data, I can really start to get the richness in my digital twin that I had if I was like literally standing there with it and had test instruments and that I could control it. So that's how we're taking the data, applying the analytics to then get the benefit and the richness in the digital twin.
Wonderful. So we have the meaning behind the data, we have analytics use cases. So that's kind of a lot of where we are today. So let me ask Eric a question. So this panel is entitled Embracing Digital Twin. Last year we had a similar panel with Eric on it called Implementing Digital Twin. So I assume if you're on last year's panel, you've implemented it, now you're embracing it. So what are some real use cases of Twin today? Like, what are people actually doing?
Well, if you think about all that we're discussing today, a lot of it is familiar to you, whether we need to know whether 100 is in degrees or in foot-pounds. Also, if we think about Brad and his discussion about the value, that's what we want to do. We want to create value. It doesn't really matter how we do it. I think the opportunity is that here we're taking things and maybe packaging them a little bit differently. We've already been doing digital twin for a while. I'm not just saying me, all of us, right? So think about client server. If I have client server architecture, I have maybe a back end where I am querying data from that, and I keep a cache of that in the client. Well, that client is in some ways the digital twin. Service-oriented architectures. We have multiple architectural components communicating with each other, and they all have their own understanding of the world as they see it, and they have boundaries about what is outside of their component and what's inside, and that component is in some situations perhaps the digital twin. So a database, right? Maybe I have not only a back-end database, or how about let's think about a cloud. A cloud is, if you think about the entire cloud, it's like a digital twin of the real world, right? So because this is not new to us, right, and I think everyone is already doing this, why would you want to repackage? Why would you want to embrace this and repackage things? And I think the reason why is because, in some sense, have you ever heard of the expression, it's turtles all the way down, right? So the world, there's this myth about the world, and how is the world supported? Resting on the turtle's back. And someone asked the hard question, well, what's holding that turtle up? Well, it's turtles all the way down. So if we can use an architectural view of digital twin, perhaps to integrate the assets, the representations of the assets, wrap an AI as a digital twin, I think that's where we really get to the point where interoperability is much easier and the total cost of ownership can go down.
Great. So the data story is you're saying that many people who have done service-oriented architectures, APIs, microservices, containerization, they are already on a digital twin journey. They just may not know that they are. So with that viewpoint, now how many people do you think are doing digital twins? Is there more?
Less.
I think it's about the same. Maybe let's give an AI perspective. So when we talk about AI, you've been doing AI for a while now. But what is a view of digital twin now? Is there different sorts of unconventional data that you're tapping into more now that we have this digital twin moniker?
Yeah, so what's interesting when we get artificial intelligence going, you'll hear about different techniques and algorithms that are used, computer vision, and we think of things like facial recognition, recurrent neural networks for natural language processing, where you're taking speech and working with the patterns in speech and such. And your first thought is, well, okay, that's interesting, but is that going to help me at all? And actually those same techniques can be applied to the digital twin world that we're discussing here. In terms of like a building, yes, we're getting data off all the sensors within the building and the environment around it, but a lot of part of the operation of the building is the occupancy and the usage. How do I get information or data about that? Well, I can put up, I've already got security cameras in a lot of places, so I can use computer vision on that to get more in depth of how the traffic flows, the people flows within the building are. I mentioned with natural language processing, there's a technique called recurrent neural networks there, and that's used for sequence and complex sequence and time series data. Well, with all the sensors that we have in IoT, it's data points over time, and we're looking for interesting sequences and patterns within that. So that's another technique that you might not hear a lot about in the popular press for artificial intelligence, but it definitely applies to us for our digital twins.
Wonderful. So we've talked about, semantic meaning and then data, how that actually applies to your data architecture, and then these different types of AI techniques. Some are unique to, or more applicable, I would say, for digital twin. So I think, Birgit, now going back to you, how do we interoperate? Like, ideally, all these things work together. Do you think these twins that are created are domain specific? How much can be reused?
Yes. So we have to distinguish, as I said before, the semantics. So this is the information you are transporting via the digital twin. This is, of course, extremely domain specific, and you need a lot of expert know-how to do these models, except for some generic things that are also available, like documentation. Very important. It sounds easy, but it's very important to have such simple stuff also, the documentation that belongs to your asset. But all the other models are typically very domain specific. But what is not domain specific, and here I'm quite convinced, and okay, we are discussing it in several committees, whether, for example, the asset administration shell is now specific for the manufacturing domain. And I'm saying no. So what is not specific is the digital twin itself with a standardized API, a standardized way to access the information. So this does not need to be domain specific. So I'm not sure whether we will be successful in having one specification and one standard for digital twin in the end. But I personally strongly believe that this would be possible, and I would love it, because only then we could also have cross-domain use cases supported in the end. So this is what we are all dreaming about. But in the moment, every domain is doing its own stuff and in its own committees. And of course, the German platform industry 4.0 is no exception, I know it. But nevertheless, I hope, and that's why we are also going into international standardization, that there will be one standard for the twin itself, and then we go for the domain-specific semantics that the twin will transport to your applications you build on top of the twin. And I think this is, that what I would love to see in the future, 5 years. We are not yet at the final, at the finish.
Does anybody else want to comment on that of the panel as to this interoperability question?
Yeah, so Birgit, you mentioned APIs. And as a software architect, that's where things resonate with me. In our work at ABB and also with the Industrial IoT Consortium, we identify 6 different sets of APIs. So certainly if I have a digital twin, I need to administrate it. Information model, this is the semantics, would be a second. The third is data exchange. So if there's data in it, I need to be able to create, read, update, and delete data. So now we get a little bit more in the fringes. I believe a digital twin could be a publish-subscribe bus. So let's have some APIs associated with clients subscribing to digital twins. There's another kind of interesting aspect, and when we get back to the different architectures in the past and how we've tried to address the architectural quality attributes, a digital twin might not always be connected to the real asset. And yet I want to operate on that digital twin as if it is the real asset. So we need to replicate data from the asset to the digital twin. Hey, if the asset was wrapped as a digital twin, it's just digital twins talking to each other. And then the last category would be around the interoperability is that I need to be able to discover digital twins, understand what their properties and characteristics and capabilities are, so then I can integrate them into my applications.
Okay, so let's talk about the next phase, right? So have we seen any of this at scale? So maybe I'll start with Brad. Are there examples of industries that are more mature than others and are doing digital twin at scale?
Yeah, most definitely. I've run some of the ones that I have been working on. They already have this functioning. I've been talking about buildings a lot. You know, many of the new pretty much all the new modern buildings have this type of technology in them and being used. So you know, on the scale of thousands of buildings. So it's a pretty good scale going on there. You know, vehicles is another one that you're starting to build it out, and just because it's deployed in millions of places, you see it there. That makes you have to grapple with a lot of the challenges that come with scaling up. One of those that we have to work with a lot are, as I mentioned, these artificial intelligence models and updating them and getting the updated models out to the individual assets. I do a lot with edge computing as part of this. Maybe we'll talk about edge computing related to digital twins as well. So you're building these models, but there's just a logistical challenge of moving them around. So that is developing a lot and progressing well to be able to drive that scale.
Are there the other examples as to scale?
Yeah, so if you think about the power grid, right, and all the assets that are in, it's a distributed plant. Certainly in local or regional aspects, what they experience and what they contribute to collaboratively. You don't really think about a transformer as a collaboration entity, but that's where some of our work is going. So I was privileged to be able to develop a serverless framework where, if you think about digital twin, okay, it's a microservice, right? So let's have a microservice for a transformer, for a breaker, for a solar inverter, right? And if you have worked in microservices, every microservice has a different set of APIs. And so that can be like a cacophony of information that you have to use to develop your applications. Well, let's standardize on the APIs, but the information models for each one of these is going to be radically different from each other. So let's use what we learned from microservices and say the information models can be completely different, and yet I still build my applications on top of them. So what we did with this serverless framework is we had each of these components knowing the data associated with its asset and then be able to compute. Specifically, I know Brad's done a lot around time series analysis and recurrent neural nets to have them be able to keep a history of what they experienced and then be able to predict in the seasonality and the cycles of what you would expect each asset to be able to contribute to.
Very cool examples. I'm really struck by the ones that have scaled the most. If we think about Birgit starting with this need for semantics, I think if we were to globally model transformers, right, or globally think about what's in a smart building, those are things that might be easier for us to come to agreement upon, versus if we were going to talk about what's in a big plant, I think there's just more turtles that need to be defined. Is that? So I have one more question for the group, and then please think about questions that you might want to ask, because I'm going to put it to the audience right after this. So I have a question with Birgit. How do we get started? So we have great examples of scale. I think in the audience, there weren't too many hands up for either definitions of twins. So how should people get started?
Okay, our experience in the platform industry 4.0 was that the idea of the twin was highly appreciated by a lot of people, and everybody implemented a twin, and everything was fine, but they were not interoperable. So we did a specification for developers, and it was published last year. So, and And then we also did, and this was the second step, open source implementation for an editor that is realizing the specification. And I think without this open source implementation, we would not have come as far as we did, because now really everybody of you can download this editor. It's a prototype, of course, but you can start developing now your first twin, your first model of a twin. It's not, everything is not yet in place, as Eric said, infrastructure services and the API and all of this, but this is step by step what you do. And the first thing is to think about the semantics, about the information you want to share with your digital twin. So this is the first step, and this you could do with this editor in a standardized way. And so is everybody, as I told before, if everybody is specifying the information, your domain know-how in the same way, then the stuff will get interoperable in the end. And this is why I recommend to all people, just download this tool and start with your first twin. Start simple. Don't think you need to model the complete asset in all its aspects. Start with small aspects. Start, for example, with documentation, with the technical data, whatever you think of. Just start. And then get your experience, and then I think we have all the experience we need also for international standardization, because only then we have the use cases and you get new ideas what you can do with it and so on. This would be my recommendation, and we did very good experience with this.
Okay, are there any questions? I think we have one up here. Could you please introduce yourself when you ask the question first?
Sure, I'm Don DeLoach from Rocket Wagon Venture Studios. Brad, your comments about augmenting the data with data beyond just the physical asset itself, I think makes the statement that the AI and machine learning and all of your analytic models are going to only be as good as the data you curate underneath that. But that data requires that you get it from a variety of entities. What are your thoughts on the role, the status and direction of data governance and data ownership as it applies to fulfilling that vision?
Mm-hmm. Yeah, and Eric was talking a little bit earlier about the APIs and the interchange between that. It's a very interesting topic. We get into data, governance and provenance. I definitely realized, and when I'm working on some of the physical systems and I look at what they do, it's like this data is coming in and I'm driving it to make decisions. I need to know that this data is correct. So the infrastructure that we were talking about earlier definitely is needed to support that data governance. But the data, and then there's the data sharing. Eric was mentioning earlier about a common data bus, public data bus that you could put digital twins could put information on. People are hesitant sometimes to how much should I share? What will be the ramifications? Maybe the unknown ramifications when I do that. So there's probably going to be a little bit of experimenting and stumbling as more people put data out there. But we'll need to work through that, and it'll be kind of building that trustworthiness into that data, that data communications there. But that'll make the digital twins operate better and sufficiently for what we need to do. And one area that I'm not sure if we'll get a chance to get into much, but there's an area of reinforcement learning where now we are going and taking the results and not just feeding them back to a human who's going to ultimately make the control decision, but actually control the assets themselves and learn how to do that better and better. So as the technology is progressing, it'll be more and more critical.
I mean, that's such a great question, because I remember when we were here a couple years ago and talking about the same topic, really a lot of the drivers for twins and IoT, people were building their own platforms, right? I would build my platform, we would each have our own platform, and we would do everything within that ecosystem. What you just described about data lineage and trust, we're gonna need a partner data to actually partner models, right? Brad may use my data to train a model that then Eric deploys in his environment, right? These sorts of new ecosystems is no longer just, Teresa's platform, Brad's platform, Eric's, right? It's now us coming together. So that problem that you pose, I would say that's a really critical one that through these newer architectures that we'll need to solve. I think we had a question here.
Hi, good afternoon. My name is Ronnie Horvath with Exponential from Ecuador. We're doing 3D modeling. Basically, we work at the data center, telecom base station, and smart building vertical. And what we're doing is, let's use a use case for data centers. We're replicating the data center from our customer in a 3D modeling to be able to have real-time decision making in terms of power, cooling, and asset management. So my question is, in your criteria, is that a digital twin? Or to be considered a digital twin, should we also have information simulation to complement whatever we have already in the model?
Yeah, so we've been throwing around this term of digital twin without any definition. And I guess from my perspective, there are a number of different characteristics that a data twin or capabilities that could deliver. And I don't think we need to differentiate and say you're not a digital twin because you don't have the seventh one, right? So the answer to your question is yes, it's a digital twin. So you have to go back to the value proposition, right? And then really think then what technologies can support it. And if you can package that as a digital twin, then I think you get the benefits of the interoperability.
Now I wanted to add a little bit. You brought up an interesting topic for me with the 3D modeling. One area in digital twin, I have a colleague who works on this part, in augmented reality. So we're working on an asset that's remote, in your case a data center, and there's that whole physical space aspect to it. And if I'm a human that's trying to understand that in a remote location, how do I do that? How does my digital twin, how do I interact with it? And so augmented reality and virtual reality are the technologies that we're using there. And so you can put yourself in that space, you can move around it, you can go inside of it, you can go in and see things that are based on the data and the sensors that are not physically, if you were standing in front of it, you wouldn't be able to see. So you can kind of immerse yourself in it. So definitely interesting work you're doing with the 3D modeling as well.
So for me, I would say perhaps you are doing a digital twin, but you are not doing an asset administration shell. So for me, this is important. In former times, I always said, oh, who invented such a term like asset administration shell? I thought it's really terrible. But now, together with a specification, you can say, yes, you are following a specific specification. And then you can say, yes, I'm doing a twin according to this specification or to this standard or whatever. And then you get interoperability according to this standard. So the question is not, what is a digital twin? I think this is a term everybody can use. It's not, there is no standard yet on digital twin, what it is. There is a very generic definition and a digital representation. Of course, it is a digital representation what you are doing, so it's a twin. So for me, the most interesting will be in the end, which standards do we have and which will be the one that is the one that everybody will use in the end, or not everybody, perhaps it will be domain specific as we discussed before, depending. So how will we really gain interoperability in the end if this is needed for your use case? Of course, if it's not needed, it's not a question at all. So.
Good question. Is there any other questions in the audience? We have one more here.
Yeah, Manuel Finotto, Parker Hannifin. For instance, we are adopting the asset administration shell in our components. We are also having today in Stuttgart hydraulics event. But I also participated yesterday night to an event by Microsoft. And they are working with the BMW, car manufacturer. And they are sponsoring a different standard. And for a company like us that are providing subsystems or components, for us it's a value to have something really interoperable. We don't want to every time supplying different standards. So we see the value about classifying and everything. So the question is, do you see a future where it will be needed an API of API just to translate between one standard to the other one? Thank you.
Well, I'll say that one of the things that we can do, so we have artificial intelligence, which translates different languages. I can speak to you in English and you can hear it in Catalan. So sure, we can do that.
Yeah, it's a very difficult question, as you know yourself probably. Which standard will be the one that everybody will be using in the future? You don't know yet. So the asset administration shell is not yet an international standard, and of course it will change if it's getting, because a lot of other people are involved, and so it's how to come to a consensus and on a specification and all of this. But this is a starting point. And if it's not an international standard, you can work with open source. There is also other possibilities, but you never know who will win in the end. So this is,
Well, so I think in the end we all win. And you could think about a vertically integrated market, right? And you just make your own standard if you own that market. If you think about an industrial plant or, say, an electric power grid substation, there's a ton of vendors in there. And so it's really the customer, either the one who owns the plant, right? Or, some senior person who is providing the resources to make everybody work with each other. So having the standards, I think, is key to being able to create value for the customer. So I guess there is value even if we don't have very exacting standards, in that we're all speaking the same language. Coming back to we're all doing digital twin, is that if we just take what we already have, and then if we want to interoperate, maybe we don't have to, but if we do at some point, then when we talk to each other about that collaboration, we have a starting point where we have an agreement, if it's not the specific APIs.
Yeah, I think there will be like you said, the higher tier wrapper API, because what are you going to do right now, right? So if the standard existed, we can all just go to that standard, but business is going to move on. So we're going to model the things we need to model for our use cases, and then eventually there will be some of that need to federate right at the top to say, when we hit when the standard actually emerges, I guess you could hit that standard, and then you just need to convert your information into that standard, and then Brad converts his to that standard, and now we can work together. So I think there is hope. So start working with the specifications you have and in your industries, and then we come together. So I have one last question for the panelists. So we talked about a 5-year outlook. I don't think we gave it yet. So maybe could you each close with what your 5-year outlook is?
Yeah, sure. So one thing, working in artificial intelligence, is there's also a lot of discussion about the societal impact and implications, and that includes jobs within the market. And people get worried that, if I'm putting together a digital twin and it's got all this artificial intelligence within there, are people going to lose jobs? Well, what I'm seeing right now is there's just a lot of work that is not being fulfilled because there's not enough workers for it. I talked earlier about computer vision. And if you go into any operations center, you'll frequently see a bank of monitors with video feeds going. And, is anybody watching all those video feeds all the time? Most of the time, that video is just used after something happens to go back and figure out what happened. So with an artificial intelligence, computer vision type algorithm, you're monitoring that all the time, finding the interesting things in there. That's not replacing anybody's job. That's almost a new job that's being done by the artificial intelligence to augment what the people who are in charge of our safety are doing. You see the same thing in the mechanical systems, where there's just a lot of systems that are just not being monitored, and they're just mostly operating until they have some failure or things get so bad that it rises up the priority stack. So that's where I see, artificial intelligence and analytics fitting this digital twin, not to replace jobs, but basically do jobs that are not being done right now.
Yeah, so it's augmenting the humans with the dull, dirty, dangerous jobs we don't want to do. Eric?
Yeah, so what Brad was talking about in terms of the data is that if we're waiting for some anomaly to happen before we can actually develop an algorithm to detect that particular issue, I think that we are not delivering the best value. So simulation, I think, is really critical to our success, because if you consider an industrial plant and some asset in that plant having a critical failure, the manufacturer of that asset doesn't want that to happen. They want it to run smoothly, right? So being able to simulate individual assets and then representing those simulations as digital twins, to play what-if scenarios, perhaps, and then being able to compose all of that together into a digital twin of the entire plant, and looking at reliability concerns and availability concerns. I think that's how we can really make advances through using simulation, not just waiting for the data to arrive.
Okay, so perhaps I add another aspect, and I think what is also very interesting is cross-company interaction, that you share data you have. For example, if you are a machine builder, you would like to have the data of the operating in the factory to improve your design or whatever. You can do predictive maintenance, you can increase the service for operations and so on. So what we need is to share the data, but only the data you want to share. So you don't want to share your production data. Typically, you only want to share the data that is really needed for predictive maintenance. So what you need is some kind of tenant management or something where it's really possible to share the data you want to share. And okay, as a final word, perhaps what I'm dreaming about is that, because we are talking about digital twins, is that every product in the near future will have a standardized twin with a standardized API again, and standardized semantics. That would be great. And what we need is then cross-company, I think cross-domain, we also talked about it, and of course cross-country interoperability, and perhaps we did not yet talk about it, secure access. Security is always the last thing that you should mention, because all of this will not happen if it's not being able to, that we do it in a secure way. So this is, I think, the outlook for the next 5 years from my point of view.
Wonderful. So hopefully it's a positive message, right? So we, in the next year's time, will come back and more people have embraced digital twin, and that way we can work together, right? Because the promise is we want to work together with you, and there's very clear specifications that already exist, so you don't have to wait for the standards. 5 years we will have a standard, yes? And then we can start moving with our data and our AI to start applying those. So thank you very much